In this video, we'll talk about how to solve a system of three equations using substitution. So let's check out our example. We have three equations here, and we want to figure out for what values of x, y, and z would each equation be true. So one way to solve this is to use a method known as substitution, where we solve for either x, y, or z, and then substitute that value into the other two equations. So if we just look at our first equation here, we can see that we can solve for x very easily by moving this negative 6y and negative 2z to the right-hand side of the equation. So let's do that. We get x is equal to positive 6y plus 2z minus 8. So now that we have solved for x, we can plug this into both of these equations for x. So let's do that. So in this first one we have negative, instead of x we'll write 6y plus 2z minus 8. And then we have plus 5y plus 3z equals 2. So if we distribute this negative sign, we'll get negative 6y minus 2z plus 8 plus 5y plus 3z equals 2. So we can combine like terms. We have negative 6y plus 5y, that's negative y. Negative 2z plus 3z, that's plus z. And then we have plus 8 is equal to 2. So if we subtract this 8 from both sides, we'll get negative y plus z is equal to negative 6. So we have this equation here, and now we need to substitute x into this third equation. So if we do that, we'll get 3 times x. Instead of x, we'll write 6y plus 2z minus 8. And then we have minus 2y minus 4z is equal to 18. So if we distribute this 3 into each term in the parentheses here, we'll get 18y plus 6z minus 24 minus 2y minus 4z is equal to 18. So we'll combine like terms again. 18y minus 2y, that's 16y. 6z minus 4z, that's 2z. And then we have minus 24 is equal to 18. So if we add a 24 to each side, we'll be left with 16y plus 2z is equal to 42. So that is our second equation. All right, let's erase a little bit and make some room here. Okay, so these are the two equations that we have. Now we need to perform substitution one more time. So if you'll notice in this first equation, we can solve for z very easily by just moving this y to the right-hand side. So we would have z is equal to y minus 6. And now what we can do is we can substitute this value for z into this equation right here. So let's do that. So we get 16y plus 2. Instead of z, we're going to write y minus 6 is equal to 42. So we get 16y plus, if we distribute this 2, we have 2y minus 12 is equal to 42. So 16y plus 2y is 18y. If we move this 12 to the other side, we get 18y is equal to 42 plus 12 is 54. And if we divide both sides by 18, we'll get y is equal to 54 divided by 18, which is 3. So we have solved for one of our values. We know that y, or one of our variables, we know that y is equal to 3. So now what we can do is we can jump back up here and just plug in a value of 3 right here for y to figure out what z is. So we can see that z is equal to 3 minus 6. So z is equal to negative 3. So we have solved for y and we have solved for z, and now we can just plug both of those values all the way up here into this equation. So we get x is equal to 6y, we found that y is 3, plus 2z, z we just found is negative 3, minus 8. So we get x is equal to 18 minus 6 minus 8. So x is equal to 18 minus 6 is 12, 12 minus 8 is 4. So our final answer we can write in the form of x, y, and z. So 4, 3, negative 3. That is our final answer. And you'll find that if you plug in these values for x, y, and z into any of these original three equations, they will be true.